Hi everyone. We are going to be taking some notes for 1F, and this is a skill where we're going to be translating between words and math. So the reason that it's important to learn this skill is because it's very valuable when we're trying to do problem solving or real world problems. We need to know how to take those symbols and translate them into words, or take those words and translate them into symbols. So let's go ahead. My page looks a little bit bigger than yours because I just wanted to be able to write and you be able to see them. But this is the front side of your notes over 1F. So let's get right into this. So a numerical expression is a problem, a math problem, with numbers that doesn't have an equal sign. An expression doesn't have an equal sign, so no equal sign. Now there are many ways that I can write this problem that I've got here by using words. So I could write 28 added to 37, added to 37 is one possibility. I could write 37 plus, oops, sorry about that. 28, let's kind of bullet these so that you can see my separation here. I could write the sum of 37 and 28. And I could write 28 more than 37. Now there are maybe other possibilities, but here are several. So 28 more than 37. So let's underline those words that mean add. Words that mean add. Words that are plus. Added to, plus, the sum of, or more than. We'll come back to this algebraic expression here in a little bit. All right, let's move on to subtraction then. So I'm going to use the expression, because it doesn't have an equal sign, 90 minus 12. And it's a numerical expression because it has numbers. All right, so here are some options for subtraction in the written form. We could do 12 subtracted from 90. Now notice that the 12 and the 90 kind of switch place here, right? Because we're taking 12 and we're subtracting it from 90. That means we start with 90 and we take 12 away. Be really careful with this situation. Kids oftentimes will want to write 12 minus 90, and that's not what this phrase is saying. This phrase is saying start with 90 and take 12 from it. We could do a very simple 90 minus 12. We could do the difference of 90 and 12, and the order is important there. When you have the difference of 90 and 12, we write the 90 first because the 90 is the one that's going to subtract the 12. When you have the difference, you write the number that will go in front of the subtraction symbol first. And we could do 12 less than 90. Again, reverses the numbers there, so be careful. 12 less than 90. And then one last one, we can take 12 away from 90. Another one that reverses the numbers. All right, let's underline those words that mean subtraction then. So we've got subtracted from, and that's a case where the numbers would have to switch the order that we see them in the problem. 90 minus 12, notice in that situation the numbers stay the same order. The difference of 90 and 12, and again the numbers stay in the same order. 12 less than 90, there's a situation where the numbers are switched from the math problem. And then take 12 away from 90, so take away, and that would be, again, another situation where the 12 is first and the 90 is second, even though in the math, the numerical expression, the 90 minus 12 goes in that order. All right, so let's look at some multiplication options here. Let's say we wanted the expression, the numerical expression 8 times 48. Now, there are a number of ways to write 8 times 48 in mathematics. So we could write 8 times 48, which is what you're used to seeing, but we've talked about the fact in class that we oftentimes will do 8 times 48 where the dot is the multiplication symbol. And the reason that we do that is because we don't want to get our x for the multiplication symbol mixed up with our x being a variable when we're working on algebra. You might see 8 and then parentheses 48. That's going to mean 8 times 48. You might see the 8 in parentheses and then the 48 like that. That also means 8 times 48. Or you might even see that they're both in parentheses, and that still means 8 times 48. So all of those mean 8 times 48. All right, so some words then that would mean multiplication. We could do, of course, 8 times 48. We might write 48 multiplied by 8. We might write the product of 8 and 48. And finally, we might write 8 groups of 48. All right, so words that are going to mean multiplication would be times, multiplied by, product of, groups of. Okay. Go back over here and color code my minus sign. All right, finally then, we want to know how we can write division in words instead of numerical expressions. So the numerical expression we'll look at is 327 divided by 3. Now, there's another way that we might write division when we start working with algebra and higher mathematics, and it's like this. It looks like a fraction, because really all a fraction is just a division problem. And so 327 over 3 is a division problem. All right, some options here then. 327 divided by 3, just real straightforward. 327 divided by 3. Or we might see the quotient of 327 and 3. Now again, when we write the quotient of, it's important that the numbers are in the correct order, that the 327, the number we're dividing into, comes first, and the 3, the number we're dividing by, comes second. Just like over here where it mattered about the difference. We had to write the difference of 90 and 12. There's no way really to tell which number should come first except for the way they're written. That's the same thing over here. Okay, so that's a shorter list. We've got the division here, and we could have divided by, our words that mean division, and quotient of, our words that mean division. We could also put 327 divided into 3 equal groups. Anytime we're dividing into equal groups, that's going to be a division problem. So divided, and we want to think equal groups. When we're doing equal groups, think division. All right, now we're going to move into our algebra here. And algebraic expressions are similar to numeric expressions, except they use variables. So instead of numbers, one of the numbers may be replaced with a variable or a letter. A variable is just a letter that stands in for a number. And so we could have the algebraic expression x plus 28. And then we could take this x plus 28 and write it in words by adding any of these phrases up here. I'll just do a couple for you. So this could be x added to 28. It could be x plus 28. And again, we could do x and the sum of x and 28, or 28 more than x. Okay, so in this case you can see the x was standing in for the 37. All right, we could do k minus 12. And again, we could replace any one of these combinations with these words with the k and the 12 to make our written expression. So we could do 12 subtracted from k. Or we could do the difference of 12 and k. Or any of these other phrases up here in this section. All right, and then we're going to look at multiplication expression. And so these, again, have several forms. It might be b times w. I'm sorry, let's do that again. It might be 8 times w. Or it might look like 8 times w. Or it might look like 8w. And most often, you're going to see it this way. This is really the most often form that you're going to see multiplication. So you're going to want to get used to that. When it's a number and a letter next to each other, that means multiply. All right, and so again, we could take any one of these and use 8 and w, but I'll just do a couple. So we could do 8 times w, or the product of 8 and w, and again, so on. All right, then we've got our algebraic expression with division. So n divided by 3, or again, n over 3. Both of those are going to mean division. And I'll give you a couple examples there. So n divided by 3, or the quotient of n and 3. So there you have it. You've got an algebraic expression or a numerical expression, and then the word equivalents. So the way they look as numerical or algebraic expressions, and the way they would look as written words. And again, this is a really important skill because it helps us in our problem solving. And of course, that's where we want to go with math, is to actually be able to solve problems with it. This is the first part of these notes, so go ahead now and watch the rest of the videos to fill out the rest of your notes. And we'll practice this in class.